All right, section 9.9 talks about applications of marginals and derivatives. Typically when they mean applications, they mean word problems. Now when they're talking about marginals and derivatives, they're talking about marginal revenue, marginal cost, and marginal profit. When you talk about revenue, cost, and profit functions, they're typically linear, but in this course you're going to be getting ones that are non-linear, meaning quadratic, cubic, quartic, degree 2, 3, and 4. And to find the marginal revenue, marginal cost, and marginal profit, you just have to take the first derivative. And so we're talking about taking each one of these different functions and taking the derivative and being able to make conclusions based on that. So in 9.3 we talked about marginal revenue based on what total revenue was, and we took the derivative to find marginal revenue. Now we're going to be talking about marginal cost and marginal profit as well. So we saw earlier that instantaneous rate of change is the same thing as the derivative of the total revenue function, which also equals the marginal revenue function. And the same follows for the cost functions and the profit functions. They are also derivatives, and they're marginal cost and marginal profit. And marginal revenue, if R equals R of X is the marginal revenue function for a commodity, then the marginal revenue function is MR bar, with a bar over the top, equals R prime, meaning the first derivative. If the demand for a function in a monopoly market is P equals F of X, then the total revenue is simply P times X. Whatever your P is, it's some sort of function in terms of X. You multiply it times X, and that gives you your function you can call the revenue function. Alright, so here we talk about in the total cost in dollars to produce X kitchen blenders is given by this cost function. What is the marginal cost, and what does it tell us about how costs are changing? Well, you can take the first derivative. And when you take the first derivative, then you can now talk about how cost is changing and make some evaluations as to what's the best amount of blenders to make to minimize your cost. Marginal revenue is simply the instantaneous rate of change, or the derivative of the revenue function. It's called the marginal revenue function. And it's called MR bar or R prime. And again, in a monopoly market, if you got P equals some function, the revenue is simply P times X. So in example 1, you got a monopoly market, and you got P equals this equation here. And so to find the revenue, you just multiply P times X, and P is this guy, so you multiply that guy times X, and you get 16X minus 0.02X squared. When you take the derivative of that, you get this guy here, and that's your marginal revenue, or R prime. And now if you want to know what the marginal revenue is at 40 units produced, you plug a 40 in there, and it tells you that when you produce the 41st unit, it's going to cost you, you're going to make $14.40 on that one unit, that 41st unit. That's what that number means. Example 2, they got a graph of R, and it's and MR bar, and that's the same as in example 1. And you look at the revenue increases to here, and then it decreases to here. So you can have zero revenue for selling 0 items, or you can have 0 revenue for selling 800 items. You make no money whatsoever. But it looks like if you make 400 items, you maximize your revenue at somewhere around 3,000 or so. And if you look at your marginal revenue, it means your revenue is positive here, and then it becomes revenue is 0 here, and then it becomes negative down here. So if you want to find where your revenue maxes out, you look where your marginal revenue equals 0, and that's at 400. So R of X has a maximum value at 400, and at less than 400, your revenue is increasing. For greater than 400, it's decreasing. And for MR bar, the marginal revenue, for X less than 400, your marginal revenue is positive. And for greater than 400, it's negative. And at 400, it's 0. So it has a max at X equals 400, and at 400, your marginal revenue is 0. That makes perfect sense. Here, for less than 400, your marginal revenue is positive, meaning your revenue is increasing. Here your marginal revenue is negative, meaning your revenue is decreasing. So to maximize revenue, total revenue here, 400 units should be produced and sold. And we can use the same logic here for cost and for profit. So let's look at marginal cost here. If you take the cost function and take the derivative, you get your marginal cost, or MC bar, or C prime. And they want to know what's happening at 80 and at 200. So you plug in 80 into the derivative, and you get $3.20 per unit. And what that means is it will cost you $3.20 to produce the 81st unit. And plug in 200 in here and you get $32 per unit, and that means that the cost of producing the 201st unit is $32 versus the cost of making the 81st unit is $3.20. So you have a dramatic difference in the cost per unit. All right. So if you look at the total cost, your costs increase continually no matter how you're producing items. No matter how many you produce, your cost will always be positive, a positive number, or zero. But if you look at the rate of change of your cost, your cost has a minimum here at 100, so it would look like you'd want to produce 100 units to minimize your cost, and the cost per item is less than $5 here. And so the graphs of many marginal cost functions tend to be U-shaped. They eventually will rise, even though there may be an initial interval where they decrease. Looking at the marginal cost graph on the previous page, we saw that the marginal cost reaches its minimum near x equals 100. We also see that for the original cost function, that the tangent line drawn to the total cost graph will have a slopes that decrease until at about 100, the tangent line has a slope of 0. And there's several things we can say about cost functions. We say the total cost can never be negative. If there are fixed costs, the cost of producing 0 items is positive because you've got to pay a fixed cost to start with. Otherwise, the cost of producing 0 items is $0. The total cost function is always increasing. The more units produced, the higher the cost. Thus, the marginal cost is always positive. There may be limitations on the units produced, such as those imposed by plant space. Alright, so they give you the graph 9.36. This guy here is your cost graph. And they want you to estimate the cost of producing 400 items. So you look at x equals 400, and you're looking at somewhere around 50,000. Alright, so the cost of the 401st item is MC of 400, and that's about, if you take the tangent that touches right at 400 there, it also crosses over here at 40,000, so you can use the 0.040,000 and 450,000, and you take the slope formula for that, and you can say the marginal cost of producing the 401st item is $25. Approximately $25 to produce that 401st item, whatever items they're making here. Now it says, will producing the 151st item cost more or less than producing the 401st item? Well, the slope here of the 401st item is pretty small, but the slope of producing the 151st item is a lot steeper. So we would think the 151st item's cost is going to be more because it has a steeper slope than the 401st item, which is a lot smaller slope. Marginal profit is simply taking the profit function and taking the derivative. It's MP bar is how you denote it. So P equals this function here, and you can rewrite it with a 1/2 exponent. The derivative, or MP bar, is 20 times 1/2, that to the negative 1/2 times the derivative of what's inside, which is just a 1. Derivative of 2x is just a 2. The derivative of 22 is 0. And when you simplify that down and clean it up, it looks like this. And now they ask you to find the marginal profit when you're producing 15 units. So you plug in 15 into this and you get 50 cents. So the profit from selling the 16th unit is 50 cents. Number 6, a firm is in a competitive market, must sell its product for $200 per unit. The cost per unit per day is 80 plus X, where X represents the number of units sold. Find the marginal profit. Alright, so when they tell you the cost per unit, you just take that and multiply it times X, and that gives you the cost function. So 80 plus X times X. So there's your cost function right there. Whatever the price is they're selling it for, you multiply that times X to give you the revenue. The revenue is simply the price you're selling it for times X. So now you got your cost and you got your revenue. And they want to find marginal profit, so you first have to find profit. So profit is simply revenue minus cost, so revenue is 200x, cost is 80 minus 80 plus x squared. And when you drop the parentheses and distribute that negative sign, you get this, which simplifies down to here. That is your profit function. So your marginal profit is simply the derivative of that, which is minus 2x plus 120. All right. Number 7. It shows you revenue and shows you cost, and it says if 100 units are produced, will producing the 101st item increase or decrease your profit? So at 100, your revenue is quite steep, and your cost is not as steep, so your revenue is higher than your cost. Remember, the slope is going to tell you how much you're going to get for each unit. So the marginal revenue is greater than the marginal cost, which means you're going to make a profit, because revenue is higher than cost. At 300, you've got a cost tangent line about here, and up here at 300 you got a revenue tangent line that's steeper as well, so the revenue off of the 301st item is going to be greater than the cost for making that 301st item, so you'll be making a profit there. Now if you go to 1,000 over here, now your cost is quite steep, but your revenue is not as steep, so you got a greater cost than you do the amount of revenue coming in with 1,001 units, which means the cost of making the 1,001st item will exceed the revenue from selling the 101st item. Thus, the profit will decrease when you produce the 1,001st item. Number 8, they give you the profit function here, and they give you the derivative here, and they want you to graph this. And so here's your profit function, and here's your marginal profit, or P prime. And they say use the graph of P and P prime to determine the relationship between the two functions. Well, profit is increasing between 0 to 24, and then it's decreasing from 24 or greater. Marginal profit is positive from 0 to 24. And the profit is decreasing after 24, and the marginal profit is negative after 24. So what is the marginal? When is the marginal profit 0? That's when x equals 24. All right. And they say what happens to the profit at this level? Well, the profit is decreasing at that level. How do I know it's 24? Well, because you take the marginal profit and you set it equal to 0. You bring the 2 to the other side, makes it positive. And then you write that as 2 over 1. And you can cross multiply and you get this guy. Divide by 2 and you get this. Square both sides and you get that. Subtract 1 and you finally get x equals 24. That's how we got the answer there. This is at the end of the chapter. It's in the textbook, and it talks about each of the different topics from each of the different sections. You might want to look that over. You've got, let me focus it. We talked about limits, one-sided limits, properties of limits, and polynomials, limits of rational functions, indeterminate forms, and piecewise functions. We talked about continuous functions, limits at infinity, vertical and horizontal asymptotes. We talked about average rate of change, average velocity, instantaneous rate of velocity, change, velocity, derivatives, derivative notation, marginal revenue, slope at a tangent, tangent lines, differentiability, and continuity. We talked about all the different derivative rules, the power rule, constant rule, coefficient rule, sum and difference rule, product rule, quotient rule, chain rule, power rule. Derivative formulas are summarized, second derivative and higher order derivatives and acceleration. And then in this section we talked about marginal revenue, marginal cost, and marginal profit. So now let's look at the questions that are similar to the ones you'll see on your WebAssign homework. So the first one, it says if the total revenue function for a product is R of x equals 4x, what is the marginal revenue? So you just take the derivative of 4x and you get 4. What does this marginal revenue function tell us? It tells us the sale of each additional item will bring in $4 of revenue. Number 3, R equals this. Find R of 100. So you plug in 100 there, and you get 6,200. And what does that tell us? It means the revenue from the sale of 100 units is $6,200. B says find the marginal revenue. So you take the derivative of the revenue function, and you get this guy here. C says find the marginal revenue at x equals 100, and what does it predict about the sale of the next unit and the next 3 units? So you plug in 100 into the marginal revenue and you get 60. That means the revenue will increase by about $60 if the 101st item is sold, and by about 60 times 3 or $180 if 3 additional units past 100 are sold. D says find the difference in the revenue from 101 to 100 and explain what that represents. So the revenue at 101, you plug it into the original function here, this guy, with 101, and then the original function with 100, and you take the difference and you get $59.98. That's the actual revenue from the 101st item, $59.98, where we predicted it was 60. It's off by only 2 cents. Very accurate. Number 5, you got the demand here, P, and they want to know what the revenue function is, so it's P times X. So you take that number, that function times X, and that's your revenue, and it's in hundreds of subscribers. And B says find the number of subscribers when the company charges $80 per month. Well, remember, P is your price, so plug in 80 for P and solve it, and you get 100. So X is how many hundreds of hundreds, so that's 10,000 subscribers. Okay, so now for a price of $80 and X equals 100, R of 100 equals this, which is 8,000. And it's $8,000 in hundreds, so it's really $800,000. C says, how can a company attract more subscribers? Well, if you look at the function, you can see that they will maximize their revenue if they lower the price to $60 instead of $80. So lowering the price will actually be a good idea here. D, find and interpret the marginal revenue when the price is $80 per month. Well, when the price is 80, X is 100, we get marginal revenue is 40 hundreds, okay, and so that's about $4,000. So if the number of customers increases from 100 to 101, meaning from 10,000 to 10,100, the revenue will increase by about 4,000 or $4,000. That means the company should try to increase subscribers by lowering its monthly charge. Number 6, you've got P equals this, and you want to find the revenue, so you just multiply that guy times X, and you get your revenue. And plugging in 500 will tell you how much the revenue is from sale of 500 items. And then to take the derivative, you get the marginal revenue, and we just take this function here and take its derivative. Plug in 500 and we get 60. That means the number of units sold increases from 500 to 501 units. Then the revenue increases by $60. So marginal revenue of 500 is 60. Marginal revenue of 700 is 20. The revenue from 500 is 55,000. The revenue from 700 is 63,000. And so you get more revenue from selling the 501st item, or $60. When you sell the 701st item, you only make $20 more in revenue. So the change in revenue from the 501st is 60, while the change in revenue from the 701st is only 20. Number 11, they give you the cost function and ask you to find the marginal cost. And so you just take this cost function here, number 11, and you take its derivative. 17, find the marginal revenue or marginal cost with this function here. So when you take the derivative of that, you just get 2x. And they want to know when x equals 5, so you plug in 5 in there and you get 10. And the cost will increase by $10 when you make the 6th item. Plug in a 5, and this guy is going to tell you the cost of making the next item, the 6th one. If you calculate the cost of making the 6th item and making 5 items and take the difference, it's actually $11. But we predicted it was 10. Again, this marginal cost is an approximation. 20. Here's your cost. Find the marginal cost at 3 and tell us what it predicts about producing 1 additional item and 2 additional items. So you take the derivative here and you get this guy, then plug in 3. And there's your cost for producing the 4th item, 1 additional item. And if you want to produce 2 additional items, you multiply that number by 2. For question 23, the graph shows the total cost function. And they say, will the 101st item or the 501st item cost more to produce? Well, the 100th item is right here, and that's quite a steep tangent line slope. 500's up here, and that's not as steep. So it's going to cost you a lot more to produce the 101st item than it is the 501st item. B, does this total cost function represent a manufacturing process that's getting more efficient or less efficient? Well, here it costs you quite a bit to make 1 unit, and then as you get up here, the cost of making 1 additional unit is a lot less, so they are getting more efficient. 25, the total profit function is 5x minus 25. Find the marginal profit, so that's just the derivative of that, which is just 5, which tells you for each additional unit sold, the profit is $5. 27, they give you the cost function and revenue function. They ask you to find the profit and the sale of 500. So you find revenue, you got cost, and you take the difference. Make sure you distribute that negative sign there and combine like terms. And so here's your profit function. And you plug 500 in there, and that tells you the profit making 500 units. And marginal profit is simply taking the derivative of the profit function, and you get this guy here. When you plug in 500 and you get 10, that means the profit will increase by $10 if the 501st unit is sold. Now what's the actual price? You look at the price to make 501, the price to make 500, and you take the difference and you get $9.99, where we predicted it was $10. That's only off by 1 penny. So the sale of the 501st unit will result in a profit of $9.99. 28, you got your revenue, you got your cost, find P of 100, so profit is revenue minus cost. You take revenue, put in parentheses, cost, put in parentheses, and when you drop the parentheses, you distribute that negative sign. Combine like terms, and there's your profit. And when you plug in 100, you know what the profit is to make 100 units. It's $500. Your marginal profit is simply taking the derivative of this function, and you get this guy here. Plugging in 100 in there tells you the profit of selling the 101st unit is selling the 101st unit. So you lose $4 in profit when you sell the 101st unit. Now if you take the profit on 101 minus the profit of 100, that's the original profit function, and you subtract the two, you see that your profit will actually decrease by $4.10, not $4. So it's off by 10 cents. 29, it says, from the sale of 100 items, 400 items, and 700 items, rank the smallest to largest the amount of profit received. So C of 100, I predicted it's about, C of 100 is about 18,000, C of 400 is about 24,000, C of 700 is about 40,000, R of 100 is 12,000, R of 400 is 38,000, and R of 700 is 49,000. And so the profit is simply the difference between 18,000 and 12,000, so it's negative 6,000, it's a loss. And then 38,000 minus 24,000 is a positive profit of 14,000, and then 49,000 minus 40,000 is 9,000, so that's a profit of $9,000. So now what's the profit in rank? Well, the profit of 100 is the smallest one, profit of 700 is the next largest one, and the profit of 400 is the largest one. If you look at this, it seems like around 500 is the point where revenue has the highest gap between it and cost, so it seems like making 500 units will maximize your profit. So B says rank them from smallest to largest. The profit from 700 is $9,000. The marginal profit from 400 is 14,000, and the marginal profit from 6,000 is $100. So the marginal profit for 700 is less than zero. It's actually negative because the cost is steeper than the revenue at 700. At 100, the revenue is much steeper than the cost, and so the marginal profit at 100 is greater. You got this guy here, and they ask you what is the rank from smallest to largest, the amount of profit received at each point. Well, the profit here is actually at a negative, and then here's your profit here is a little bit larger, and then here it's even larger. So A is less than B is less than C. Profit is simply the height of each of these points. B says rank from smallest to largest, the marginal profit. So now you're looking at the slope. So A has got a very steep slope, that's a very large number. B is less large, and C is the smallest. So C is smaller, B is a little bit larger, and A is the largest. 35. The cost of producing the price of a product in a competitive market is $300. So if you're selling it for $300, your revenue is simply 300x. The cost of producing the product is 160 plus 0.1x. So you take that times x to get your cost function. So now we know our cost and our revenue, and we take the difference between the two and we get our profit. And now they ask us how many units should the firm sell to maximize its profit. Well, this is a quadratic. So if you want to find out where you have a maximum or a minimum, you'd find the vertex. And the vertex is negative b over 2a, and then plugging that value into the function to find the y value. Well, your a is negative 0.1, your b is positive 140. So negative b over 2a gives you this, which is 700. When you throw 700 into the function, you get 49,000. So selling 700 units will maximize your profit at 49,000. 37, they give you the cost per unit is 10 plus 0.1x, so you multiply that times x to get your cost function. They're selling them for $70, so 70x, and there you go. All right, so profit is simply revenue minus cost, and you get this guy here. And if you find the vertex of the profit function, you'll find out where you can maximize your profit, and you can maximize your profit at 300 units, and your maximum profit will end up being $9,000. So if they give you the cost per unit is 0.40 plus 0.005x, you multiply that times x to get your cost. If you're selling for $10, you multiply it times x to get your revenue. You take the difference between the two and combine to get your profit, and then you find the vertex for that function, and you find that selling 960 bunnies with a price with a profit of $4,608.